The mean incubation time for a type of fertilized egg kept at a certain temperature is 23 days. Suppose that the incubation times are approximately normally distributed with a standard deviation of 1 day. Complete parts A through E below. Draw a normal model that describes egg incubation times of these fertilized eggs. So before I look at all these, I'd probably sketch one out by hand. Okay, so here's what I've done by hand, and I just did a quick sketch. Now I can look at these and see which one compares. And if we look at each of these, there's D, 23, and then we go out, so that's the mean, right in the middle, and then we go out 1 standard deviation. This one appears to be it. Let's look at the other ones, just to take a look and see what they've done. There's a mean of 20, so that's definitely not it. Here's graph C, mean 23, but then they have a standard deviation of what? They go out 2 each time. Well, that's not it for this one. And then finally, this last one has a mean of 26. So that's not it. So it was the first one we picked. For some reason, they've labeled that first one D. Okay, part B, find and interpret the probability that a randomly selected fertilized egg hatches in less than 22 days. So I recommend on your hand-drawn graph that you actually shade that, as I've done here. And now we can use technology to figure this out. So let's go ahead and put in our applet again. I go to Stat, Calculators, and Normal. The mean here was 23. Standard deviation is 1, and we are looking for less than 22. As I mentioned in earlier videos, less than or less than or equal to are exactly the same thing. There's no probability at each individual point. So we get, it says round to 4 places, so 0.1587. I actually can get StatCrunched around, but not really worth it. So let me show you on TI what that looks like. Second distribution, number 2, normal CDF. Upper is the negative infinity, so I'll leave that negative 1E99. Upper is at 22. The mean was 23. Standard deviation was at 1. If you don't have that statistic wizard, it's lower bound, comma, upper bound, or left bound, comma, right bound, however you want to look about it. Mean, comma, standard deviation. We get exactly the same thing, 0.1587. Again, I have my mode set to round to 4 places. So I hope that helps for those 2 parts. Let's keep going. Okay, so if 100 eggs were randomly selected exactly 16, so that's about 16%. I don't like that word exactly, right? I mean, we're not expecting exactly. So in every group of 100 fertilized eggs, we expect 16. No, not in every group. So be careful those key words there. Every group, not every group. If 100 fertilized eggs were randomly selected, yes, this one here. So 16 of them would be expected to hatch in less than 20 days. Let's keep going. Find and interpret the probability that a randomly selected fertilized egg takes over 24 days to hatch. So let's use our technology here. Brought back in StatCrunch, and we're going to change this to greater than, and we're looking at more than 24 days. And we get about the same, in fact, we get exactly the same probability, right? Because we have that perfect symmetry. We're at 1 standard deviation above and 1 below. So 0.1587 again. And on the calculator, it'd be very similar. I can actually just change this. Well, let me go into the wizard, I guess. Normal number 2. And this time it's going to be 24 is my lower bound. Upper bound is infinity, so 1, E, 99. Everything else stays the same. I've got 2 normal CDFs in there. Let me clear this out. I had like an embedded normal CDF. I've never done that before. So 24, keep everything the same. There we go, 0.1587. Okay, so very similar interpretation. In every group? No. Exactly? No. It's going to be this B part. You know, we sort of expect 16. Wouldn't be surprised if you're a little bit less, a little bit more. Find and interpret the probability that a randomly selected fertilized egg hatches between 21 and 23 days. Okay, again, technology. So this time on the StatCrunch calculator, click the between button. The mean's still 23, standard deviation is 1, but this time we're changing the between 21 and 23 days. Press compute. We're still doing 4 places, and that always glance to make sure it's shaded right. Looks like it's shaded right between 21 and 23. 0.4772. Similar on the TI. Second distribution, number 2, between, I've already forgotten what they were, 21 and 23. Everything else stays the same. We get 0.4772. Okay, we should be getting better at this interpretation. Is it in every group? No. Is it exactly? No. We would expect, out of 100 eggs, we'd expect about 48 of them, right? I'm just rounding that 47%, 47.72%. Okay, the last one. Would it be unusual for an egg to hatch in less than 20 days? So using my StatCrunch, let's go back to the standard and let's see what this is when it's less than 20 days. Ooh, that would be unusual, wouldn't it? That is at 0.0013, right? 0.0013. So the probability is 0.0013. Very unusual. 0.13%. So it would be unusual since the probability is definitely less than 0.05. Okay, so I hope that helps.